2 to the 3rd power times 2 to the 4th power. We're rewriting these as a power of 2. So when you think you know how it should be rewritten, put your thumb up. Rewriting it as a power of 2. How would that be rewritten? Think you know how it should be rewritten. Andre, what'd you get?
2 to the power 7.
2 to the power of 7. Did anyone else get something different? Damien, what'd you get?
I got 2 to the power.
Okay, 2 to the power of 8. Anyone else get something other than those? Alright, so Andre, how'd you do it?
I just like added the exponents,
Out of the exponents, and why would you think to do that?
because if you're just like, since both of them are just like 2 times 2 and then just repeat it, like you just add them to each other, but they just keep repeating each other.
Okay, good. So this is a standard from 8th grade, actually. You guys should have covered all the exponent rules. On the paper, there's a chart that says exponent rules there as a key, so you could kind of look to that as a hint. But yeah, the explanation is correct. So exponents tell you to multiply that number by itself that many times. So 2 to the 3rd is 2 times 2 times 2. 2 to the 4th is 2 times 2 times 2 times 2. How many 2's do I have? 7. So another way to write that would be 2 to the 7th power. And so, yeah, a shortcut to that would be just adding the exponents, like how it says in your chart, because that is really what you're doing. So now that we've gone over one, you might know how to do the next one. So those of you like trying it, please don't give up, like just spend your time thinking about what the answer should be. If it's 2 to the 5th power times 2, how could we rewrite that? Put your thumb up when you think you know. Everyone a chance to at least think about it before I call. John, what do you think it is? Okay, how could I rewrite that with like an exponent? Two to the power of 6 for the final written part. Did anyone get something different? Brooklyn? 2 to the power of 5. And get something other than that. Okay, so yeah, let's expand it because that really does show you why it is gonna be this answer that I've not told you which one is right yet. But 2 to the 5th power tells you to multiply 2 by itself 5 times. And then you have this other 2 to multiply it by. How many 2's do I have total? Say louder. So it is 2 to the 6th power. But this is a common mistake that students make because what I think you're doing in your head is 5 times 1. Because what's the exponent if it's not written? Class. What's the exponent on this 2? It's a 1. So every number is to the power of 1 unless it says otherwise. All right, so and following that product rule that's on your chart, that says that if you have the same base, and I know your chart might use something differently, like different letters. I like using X's for the base. But if we're timesing 2 numbers of the same base and they have exponents, you really are just adding the exponents together. And if the exponent's not written, it's a 1, so 5 plus 1 is 6. Questions on that? And also that makes sense because like, usually when you multiply by something, it changes. It doesn't just say that answer. I mean, unless you're multiplying by a 1, but common mistake there, so I'm glad we addressed it. Now switching it up a bit. 2 to the 10th power divided by 2 to the 7th power. When you think you know how to rewrite it as a power of 2, put your thumb up. What'd you get? 2 to the power of 3. Anyone get something different? All right, then let's see. So 2 to the power of 10, that tells you to multiply it by itself 10 times, so I'm gonna do that. Do you have a Caitlin for like a minute or 2? Yeah. 2, 3, 6, 7, 8, 9, 10. And that's all being divided and the fraction bar means divide, so I'm gonna use that by 2 times itself 7 times. Okay, so that's what it looks like expanded. Do you need to do that? No, we'll show you the shorter way. But here's why the answer is 2 to the 3rd power. When you have the same thing on top and bottom of a fraction, what happens? It cancels out to 1. So like 2 there, another set. These are canceling until I run out of 2's on the bottom, and all that's left is 3 2's on the top, which 2 times 2 times 2 can be rewritten as 2 to the 3rd power. A little shortcut to that is one of the rules that's on your table, the quotient rule. And they might use different letters on that table. I'm gonna write one with X's because I prefer X's as the base. But if you're dividing 2 numbers with the same bases and they have exponents, a shortcut to doing this would be to just subtract the exponents. So whatever the numerator minus the denominator, 10 minus 7 is 3. All right, last one for the warm up. So when you think you have the answer, put your thumb up. 2 to the 9th power divided by 2. How did that be rewritten? All right, so try to apply what your classmates already helped us figure out. I'm not doing anything else. All right, Uli, what'd you get? 2, 8? Like that? Oh, okay. 2 to the power of 8. Anyone get something different? All right, and that is correct. because what is the exponent if it's not written? A 1. And I could expand it for you, but if you also just follow the quotient rule, because we are dividing two numbers of the same base, you can just subtract the exponents. 9 minus 1 is 8, so that is correct. Questions on that warm up? So there's other exponent rules. We don't necessarily need them all in this unit, but you'll see some of them. So should you need to refer back to it, that little chart is there for you as a reference. Briefly, let me tell you the goal of today. It's going to be that we are exploring exponential growth. So by the end of it, we should be able to explain connections between an equation and a graph that represents exponential growth, and write and interpret an equation that represents exponential growth. I always record mostly in this class, as you can tell, and I link it in the slides later. There are helpful videos from last year. One is the exact same lesson I'm giving you right now, and the other one is like a different way, like probably more directly telling you how to do it. Do you need to watch all the videos I post? No, but they're there just in case. The practice will be lesson 3. And remember, we do have a quiz today, second half of class. So however far we get by 10:05, we're just gonna stop and take the quiz. Because I told you this lesson I actually really like. It's a very like slow way of teaching you exponential function, but it's like giving you a small piece each day and then using it in all the lessons moving forward. So if you don't necessarily get it that day, it'll show up over and over again until you do. So just remember, the quiz is over the first 2 lessons, and it will be at 10:05 today when we take it. But first, little small activity. I don't want to take too long on this next activity, but it's also related to some of the exponent rules. It says, what does x to the 0 power mean? So first, you'll complete the table, take advantage of any patterns you notice. You're going to tell me what the question mark would have to be in each of these 2 equations in order to make these equations work. And then you're going to tell me what the value of 5 to the 0 power is and 2 to the 0 power. If you get stuck, use your page for clues or a calculator, that works too. Do that with your groups. I'll give you 3 to 4 minutes and then we're going over it. Table 7 for the table on number 1. What's the output when the input is 2? 9. And how did you figure that out?
I put 3, 2, and like do like 3 to the power 2.
Oh, okay, because right here it says what the rule is, so it didn't just say X and Y. I told you like how to find the Y, and it's by doing 3 to the power of X. Other people might have just tried to figure out a pattern somehow, which is fine too. But the right answer for the first part that you have to fill in is 9. Because 3 to the power of 2 is 9. We're gonna use a calculator for exponents. Table 8, what about for when the input is 1, what's the output? 3. 3 to the first power is 3, or really anything to the first power is just that number. And then table 9, what about when the input is 0? What's the answer? 1. And how did you figure that out?
Putting the decimals.
Put it into Desmos. That's not, like, it got me the right answer, right? Like, that's not something you're not allowed to do or anything. You could have also looked at your table and saw what exponent rule. Anyone want to look at it now? Brian?
Or it's divided by 3 each time.
Oh, that's also true. Yes, it is dividing by 3 each time. That would be a division, but it is doing that. But on that little exponent rules table, what rule is being applied when we plug in an input of 0 for this? It's called the 0 exponent rule. When you have an exponent of 0, the answer is going to be 1, no matter what the base is. Whether the base is 1,000,000 to the 0 power is going to be 1. Okay? Questions on that? All right, so then let's see, where am I? Table 1. For this next part, what does this question mark have to be in order to make it true? So where it says 9 to the question mark times 9 to the 7 equals 9 to the 7, what does that question mark have to be? It would have to be 0. That make sense, class? Because anything to the 0 power is what? And anything times 1 is just that number, right? So if it didn't change, then that must be timesing by 1. So that would have to be to the 0 power to make that 1. Does that make sense? Table 2, what about 9 to the 12th over 9 to the question mark equals 9 to the 12th? What does that question mark have to be?
0.
0 as well. So yeah. Because 9 to the 12th over something that still equals 9 to the 12th. That denominator must be 1 then, right? So to make it a 1 down here, it'd have to be to the 0 power. That's good. For some reason that was really confusing this morning. So I can briefly show you in the calculator after this next one. But any questions? All right, table 3, what's the value of 5 to the 0 power?
1.
1. Table 4, what's the value of 2 to the 0 power? 4. Feel free to use calculator, use your notes, use the screen, things that we've talked about. 2 to the 0 power is not 0. It is 1. Anything to the 0 power is going to equal 1. So let me show you something. And this will become important. Like maybe I don't have time to tell you why today it's really important, but it'll make sense with something else that's coming. Earlier, people were really confused about the 9 to the 7th power one. They were like, well, can the question mark be something else? Can it be like 24? And I'm like, no, it can only be 0. All right, and here's why. So 9 to the 0 power times 9 to the 7th power equals this in actuality, which is the same thing as doing just 9 to the 7th power. Should you make that some other number, whatever number you thought it was, like someone thought it had to be 1 or something like that, it's now not the same as 9 to the 7th power. So it would have to be 0 there. Questions on this little activity? Okay. So next part. Back to our like real world situations for exponential growth. And it is on the back side if you want to follow along. So in biology lab A, 500 bacteria reproduce by splitting. Every hour on the hour, each bacterium splits into 2 bacteria. So is my bacteria increasing or decreasing? It's increasing. So complete the table. Knowing that each hour, each cell is splitting, so complete that table. And then you're going to be making an equation so that no matter what hour we're talking about, we'll get the right answer for how many bacteria there are. So do that. I'll give you about 2 minutes to start out with. So if it's splitting every hour and we start with 500, how much will we have after 1 hour? 1,000. Then they split again. After another hour, it would be,
2,000.
what would it be at hour 3? What would it be at hour 6?
What?
Okay, so we have an answer of 32,000. Anything else for that one that you guys put? So I'm just gonna list them. I won't tell you which is right yet. Any other answers for that one? Okay, and even I made a mistake first hour because I didn't read it properly. The table jumps. Remember yesterday I told you how sometimes they try to confuse you by like not going in the same order for the X's. So it's missing some stuff. It's missing 4 and 5. So in hour 4, so in hour 3, it had 4,000. If it splits, like into each cell into 2, how much should I have in hour 4? 8,000 in hour 4. Miss Medina? I do. Okay, no problem, bye. Okay, anyway, so 8,000 in hour 4 is correct. How much would I have in hour 5? 16,000. And then if they each split again, how much do I have in hour 6? Back. Are you with me? Hello? We only got 5 minutes to get to the main point. 32,000 in hour 6. So that's why it's like that, because it jumped a few hours. That's why it's better to come up with an equation, so that way, no matter what hour it wants you to find, because sometimes it'll be like this, and it'll say, how many bacteria are there in hour 100? It's better to make an equation so that it doesn't matter what input it is. Like, you don't have to continue the pattern. You can just put it into the equation. So we're talking about exponential growth today. There's also exponential decay, but we'll save that for Tuesday. You need this formula, or it'd be helpful to have this formula so that you can easily make these equations. So you're gonna want to write this down somewhere. Star it, highlight it, it's super important. But exponential growth can be represented by y equals a times b to the x. And y equals, so this is 2 ways to write the same equation. A parentheses 1 plus r close parentheses to the t power. So A would be for your initial amount. So whatever you're starting with. And same, the A is the same for the other equation too. B, so B is only in the first one that I showed you. B would be your common factor. What you're having to multiply by to get to the next number is your common factor. So in this one, what were we having to multiply by each time?
Two.
2. And what was our initial amount for this situation? So far we have 500 times 2, and then the X could be like whatever time frame. So like if I was doing 6, I could put in my calculator 500 parentheses 2 to the power of 6, and it'll tell me 32,000. Make sense? So X and Y are input output, right? For the other equations, the reason I'm also showing you that one is because sometimes it's not like doubling or tripling or things like that. Sometimes it's growing by like a percentage, which you will see on your practice when you go do that later. So if it says it's growing by like 5%, 25%, whatever it is, that's what you put in for R. That's your growth rate as a decimal. So hopefully you know how to convert percentages to decimals, like what's 25% as a decimal? Say louder. Whoever whispered. 25% is 0.25 as a decimal. What's 3% as a decimal? 0.03 is for 3%. So basically whatever percentage divided by 100% and you'll get the right decimal. But we don't have that in the lesson today, but you'll see it on your homework, so just give it a shot. And then T stands for time, which is also like what X usually is time. For the specific example, because it's doubling each time, we use this equation, and that's how you can make this part of your graph make sense of your table. It'd be 500 times 2 to the T is what they're using for the inputs. Questions on that? I know that was kind of a bit of information. You need practice to apply it. You'll get that practice in the next week. But just like how you guys can all tell me that linear is y equals mx plus d, you need to tell me that exponential is y equals a times b to the x. Like just put it in your brain now. We're gonna do this year in geometry and in algebra 3-4. So like just get it in your head now. Exponential functions are a times b to the x. So questions on that? All right, I mentioned to you that we do have a quiz and it is 10:05 now, so I'm gonna direct you to the quiz. You're allowed to use your notes, so you can leave your notes out. But your phones have to go in backpack.